Okay, your definition. Transformations are, that term is more of a general word. A transformation is simply an operation that maps, or you might say that moves, a figure onto an image. When we look at transformations, there is a pre-image that you start with, and then there's an image after you've done the move. So it's like where it starts and where it ends. Pre-image is the original figure. In your book, they colored the pre-image blue. I wish it was green, but blue is the one to start with. And then the image is the final figure, and they color that one red. So you stop on the red one. That's your ending one. So a transformation will do something to a figure. The terminology that's used in math is, it says it maps it onto that. Pre-image is the original one, blue in your textbook. Image is the final figure, red in your textbook. Now when I copy things off, I can't copy it in color. So for what I'm copying, you need to make sure you know how points are labeled. Let's just make a simple triangle. If the original triangle is A, B, C, then when it's moved, I'll just slide it down for instance. This would be A prime. That little tick mark in this situation is just prime. B prime, C prime. So by looking at the points, you can tell which ones match up. If I wanted it to flip over, I would have put the A probably on the bottom and the B on the top or something like that to get it to flip. So the prime markings indicate the final figure when the color coding is not possible. There are 4 different transformations. You can flip a figure over, you can slide a figure, you can turn a figure, or you can shrink or enlarge a figure. So we'll, over the course of our geometry class, look at all 4 of those. Today we're going to focus on the translation, which is the slide of it. Done. iPads can go face down. It's flipped over. Okay, anyone still need the notes? Okay. The translation that we're specifically going over today is the transformation that slides a figure. When you slide it, don't think about sliding like on an icy road. Sliding just going straight. A transformation that slides a figure so that points follow parallel paths. Could be horizontal, could be vertical, could be diagonal, but not twisting, just a straight shift of it. So I gave you a couple examples here. We've got the blue arrow going directly to the right. I coded it red and with the primes to indicate that's the final figure. The check mark went directly down to do the slide. The ones going at an angle are a little bit harder maybe to draw. So I started you out with horizontal and vertical slides. notice the figure doesn't change size. It does change color, I guess, because we're coding what's the starting and what's the ending. Just took that up. All right, looks like everybody's done. Got what you need?
Nope.
Not yet? Cover on that's kind of nice, it's kind of soft.
Hey, you're good now, okay.
All right.
Thank you.
Okay, so I'm gonna take the arrow and move it. Watch my move and see if it's a translation, okay? If I take it and go this way, did I just translate it?
No. No.
Did I slide it on a straight path?
No.
Well, I went this way.
Oh, yeah, a diagonal.
So I went from here
It's still a straight path.
to, whoops, I'm missing my point. Maybe I shouldn't draw. Okay, let me try and connect it with a segment. Okay, so if I go from here to here, or if I go from this point to its matching point, or this point to its matching point,
That is a very.
are all of these the same path?
Yeah.
Yep.
Or yes.
Okay.
Oh, color that in, that'd be cool.
That's a cool.
Well, notice how it kind of, if you are thinking 3D, it kind of is looking 3D. Maybe that's what you're seeing. Yeah.
That's sick.
Recording.
That'd be sick,
Okay,
man.
need to get rid of them for a little bit.
I know what I'm talking about.
So I did create a slide. I slid it diagonally instead of just horizontally and vertically.
Yeah.
So you can go at a slide. Now what you cannot do is, you can't take it and turn it. Maybe, I guess my green thing needs to turn it. I can't turn it and slide. Now, that type of thing. Because now if I would try and match up the lines, this point went there, this point went there,
No,
this
don't
point
mess
went
up.
there.
Okay, that's not a good.
Not quite the same, is it?
Right.
So connecting the matching points, they're not parallel. You want me to connect the last one just to finish? Or is this the last one? Or is this the last one? Alright, so the point is, those were not all parallel paths, right? Because I did the twist in there, okay? Alright, a lot of lines in there, okay? And with the check mark, was that a translation?
Yeah.
Yes, okay? The check mark, okay, guys? Okay, if I go this way, is that a translation?
Yes.
Yes. What if I go this direction?
Yes.
Is that a translation?
No.
Why not?
It is, because you can still match up. Still wants a straight path.
So if I would match up the edges, would those all be parallel connections?
Yeah, I guess, yeah.
Yeah, they would. So as long as you're not turning it, and I guess, let's look at this one. What if I would, I need to activate something different. Okay, if I would, where's flip? Flip. If I flip it up and down,
Oh, wait, that's bad.
That's not.
alright, we'll switch the order. Okay, so let's flip left to right. So the point is, maybe I shouldn't use a check mark, huh?
Maybe not.
Alright, so the point is, when you flip it, it's not creating a translation. It's reflecting it rather than that. Alright, we'll go to something else here. Okay,
Okay, we can. flip
translation
this.
or not?
No. Yes, yes, wait, yes.
I've got the blue one, I've got the red one. Is it just a slide? Parallel
Yeah.
paths? Yes.
You just slid.
Slightly diagonal, to go. So yes, that one is. Translation.
No.
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 No, I had to twist it or turn it in order to get it that position.
No.
Translation, no, this was a better figure, I flipped it over. Translation,
No.
no. Again, you flipped it to
Negativity. Tilted.
that one, tilted, okay, so no. All right, so we got the idea that you have to go parallel paths. All right, now we're gonna put some on graph paper, and there's some notation that we can use related to the graphing. Okay, so in your notes, I've got some down here. Translations in a coordinate plane can also be described using coordinate notation. Now this is some notation, we'll put some numbers in here with the A and the B. But this type of notation is going to tell us how far to shift the figure. How far left or right or up or down.
So A and B have to be the same number, don't
They don't have to be, no. Because I could shift the figure like 1 unit to the right, but 10 units up,
they? I get.
so the A and the B could be different numbers. Now, when you graph, is the X left and right, or is the Y left and right? The X. So whatever the A is gonna determine the shifting to the left or the right. And then the B, that's with the Y part, that's gonna indicate the shifting up or down. So that's
Everybody got these?
notes complete?
Everybody got these? Just making sure. All my geometry skills.
Okay, now some of it we'll do up here, probably some I'll have you do on your own paper. Got some extras. Okay, first example, we're gonna place the red figure so that it is a translation of the blue figure. Move 10 units to the right and 4 units down.
We're already starting on
One that's difficult,
No, different.
different? Okay, now in order to figure out where the red one goes, it would be helpful if we picked one of the matching points on the triangles. Okay, I'm gonna pick this top point, and I'm gonna try and figure out where the top point of the red one should be placed. Okay, if I want to move that 10 units to the right, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I want it to go 4 units down. 1, 2, 3, 4. This should be the top corner of the right, or of the red triangle. Top corner of the red triangle. So I'm moving it to that same spot.
You want us to draw this?
You don't have to draw this one,
Okay.
but we'll probably draw some eventually. Now I use that top point to guide myself. Would it work if I did like the right hand point? If I started here and went 10 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 4 down, 1, 2, 3, 4. Notice I would be to the matching point there.
Well, you can work with any points, it's just gotta be done with one.
5, 6, 7, 8, 9, 10, 1, 2, 3, 4, correct. So that is the point of what I was doing there, is showing you, you can use any location on it in order to help you do the moving. Then the rest will fall into place exactly the same. Okay, now here I didn't write it out in words. What I did was gave you that notation part. So let's see if we can use the notation. Okay. What are the coordinates of this point? Why don't you put this one on your graph paper? So make an XY axis.
6, 4.
I don't think 6, 4.
Well, times.
How about -6?
-6, 4. Look at that.
How'd you get that?
How'd you get that? Just count it.
Duh.
1, 2, okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4.
Okay,
Everybody get that one? Now, without knowing where the red one needs to end up, I hope you didn't run out of space on your graph. Okay, now this -6 and 4 are the x and the y. So I'm gonna put that with my rule here. -6, 4 needs to become, now it says to get the new location, we need to take the x and add 3 to it, and the y and add 5. So -6 plus 3
-3,
and
9.
4 plus 5.
That's
So -3, 9 is where that point needs to be for the red triangle. So -3, 9. There. So that red triangle will be in that spot. So you're just using that formula to help you find where the matching point is. Now, if I would describe that with the left and the right or up or down, can you describe where that top point moved to go from the blue one to the red one? How many spaces did it move? Which direction? Did it go left or right to go from the blue to the red?
right,
It went to the right,
up,
and then it went up. How far to the right did it go?
3,
It went 3 to the right, and then it went up.
5.
Tristan, your bottle's noisy. 1, 2, 3, 4, 5 up. So we're looking at it, and it went 3 to the right and 5 up. Now look at the rule. 3 to the right, 5 up. Does that make sense according to the rule? What do you think it would be if I wanted it to go down instead of up? X minus 3. Did I say down or left? Down. Okay. No, x minus 3 would not move it down. The y minus 5 would move it down.
Yeah, but it's not minus, it's plus.
Right. If I had a minus here, instead of going to the right, it would go to the left. So whether those are positive or negative will move the direction. All right, let's try just some random ones. No, you're not gonna have a worksheet, it'll be out of the book here. Looks like I didn't get this pulled up very good. Okay, I've got the, instead of having to calculate, would this move to the left or the right? How far? Okay, to the left, 6 units, and up 1 from where it was originally, okay? That's the main thing that we were doing with the moving the red and the blue, okay? All right, let's use the last 15 minutes on the assignment so that you can get some things done.